This is an LG 32LD650N, which I picked out of the trash about a month ago, took home, proceeded to make a very nice video segment about troubleshooting the power supply on, and then deleting the video off of that. But the short story about this TV is that it had a motherboard fault. I put it aside after troubleshooting the power supply and making sure that wasn't the issue, and then one night I felt like just doing something with it, so I randomly resoldered chips on the motherboard with hot air, and lo and behold it started working absolutely fine. So either there's a failed chip on the motherboard which is gonna break again soon enough, or there was just a bad solder joint which might have gotten fixed since I used a bit of flux doing the reflowing. But either way, since this TV is now working and I'd like to use it as a secondary TV in my bed, I'm not going to settle for those puny little speakers there, so I figured we'd take this thing back apart and have a little play around with the audio amp and perhaps see what it goes for. And if you're a massive nerd like me and want to have a proper view of the model sticker, here it is. Pause the video if you're interested. Let's move on. And here are the nuts of the TV, and there's really nothing here which you wouldn't expect. You've got a power supply with integrated backlight driver to the left, which works perfectly. Modern TVs don't tend to get as many bad caps as the older one. This one is made in about 2010. And a main board to the right, and the chip I resoldered were mainly just all the BGAs. I didn't do any testing between resoldering, I just did it to see if it would do anything. And the panel model for this TV is LC320WUGSCA1. I think it's a 1080p panel because the TV looks good at that resolution, so it probably wasn't the cheapest one you could get. And here's the part of the main board that we're interested in having a look at. This seems to be the audio amplifier IC, and it's labelled NTP7100, and a quick search on the internet yields no results actually, so there isn't really anything for me to go on as far as performance expectations go. But it does seem to be a Class D device given the big chokes on the in-series with the output, as well as the filtering capacitors following them. And it's a BTL amplifier since we've got 4 leads going to 2 speakers. So we're going to have a ground sitting at half the supply voltage, or so-called ground, and we're tapping our output after these 4 0-ohm resistors there. So let's get this out, get a dummy load in, and have a bit of a look at how loud this thing will actually go. Any bets? I'm putting down about 4 watts per channel into 8 ohms unclipped, and with the original speakers being rated for 10 watts at 8 ohms, I'm wagering my bets. And here's our lovely test setup. So I've just disconnected the internal speakers. I've got the original wire with just some leads poked in going to my switchable dummy load, and on one of the channels, I think it's the right one, I've just got a scope probe clipped on, and it's going straight into my HP 339A distortion meter. So let's just crank this thing and see what it does. We're feeding it a 0.775 volts RMS signal into the analog AV2 input. So let's just play around with the volume control to see if we can affect the level it's putting out. So we are metering the output of the TV. We're at 1 volt full scale, so right now it seems to be sitting at just about 0.3 volts. So let's turn the load on. And that dropped quite dramatically, so we have a relatively high output impedance on this thing, as you'd expect from such a low-end amplifier. So let's play with the volume control buttons on the TV. Yep, that moves around. Wow. The chip is getting quite warm already. In less than a watt, I'm getting about 50 degrees on that chip. Wow, this is probably going to run into an overheating condition. And well, let's check the distortion at less than 1 watt per channel, so 2.83 volts. Well, that's about 2.8. Distortion. Must be easy, 30 kHz high pass. We're sitting at just at 0.2%, which really isn't too bad. That's not too bad at all, actually. So let's check the noise level. We'll just turn off the signal. go into level metering and see what our idle voltage is, and that would be almost 3 millivolts. That's a very noisy amplifier. Way noisier than any of the cheap Class D amplifiers you can get from China, definitely. An order of magnitude worse than the Li Pi even. So let's move on to the clipping power. I notice it runs off of a plus minus, or it runs off of a roughly 24 volt supply, because we had about 10 volts on the output sitting idle. So we're probably going to be in the 10 volt-ish RMS range when we start to clip. So yeah, we're in the 10% distortion range. Let's just turn it up until it clips. And there we go, we're into the input range. So let's see when we start to see some clipping. There, now we're hard clipping and we're at 8 volts. So yeah, it's a 10 watt per channel amplifier. Not too bad at all. This seems to have some kind of weird soft clipping feature enabled, because it took quite a bit of fiddling around with the level there to actually get it to hard clip. So the TV is just sitting at maximum volume now, so let's see how loud we can go before we start to get to much distortion at all. So let's go to the 1% full scale distortion range and just adjust the input level until we get about 1% distortion, and I'll call that our clipping threshold. That's just clipping ever so slightly, and we're now at 9 volts. If I turn the volume up, the soft clipping function takes over and decreases the output. Now I'm actually turning the volume up and you can see it dropping below 8 volts. So we've got about 9 volts per channel. That's about 11 watts per channel worth of clean power. And that's not too bad. That's certainly usable for a couple of external speakers. So let's do something about that and perhaps add a speaker output. Although since this is a TV, I am curious as to how the frequency response is going to look, because they've probably optimized that, in quote marks, for the internal speakers. So from the HP to show -4 decibels at a nominal half output power at 1 kHz. So let's see what happens when we turn that down to say 100 Hz. And we're down about 2 decibels at 100 Hz. We're down 4 decibels at 80 Hz. And we're down by about 10 decibels at 60 Hz. So that's not particularly impressive, at all. They are definitely cutting out everything that you would consider to be bass. However, since the internal speakers certainly are cutting out way above 60 Hz, I'd wager we are still standing to gain a fair amount by adding an external speaker output. And how's the high end? We're now at the 10 kHz and we are up by 4 decibels. 5 kHz, oh dear. We're up by a stupid amount. It seems that at 2 kHz we're up by almost 3 decibels. 3 kHz the same. 4 kHz a bit more. 5 kHz we're pegging the meter, so more than 4 decibels of gain. 6 kHz, 7, 8, 9, 10. Just pegging the meter. Now it seems to be dropping back down again, so let's go above 10k. 11, 12, 13, 14, 15. So that at 15 kHz we're back to 0 dB, but we've got a giant frequency response notch at about 5 to 10 kHz really, so that's not particularly impressive either. Perhaps you can adjust the TV settings to compensate for that. Alright, so through some rather careful research, I've figured out that the way any DSP functionality in this TV sound system is configured is pretty silly, because it's basically impossible to get any kind of a flat response out of it. The best I've managed to do is plus minus 4 decibels from 100 hertz to 14 kilohertz, and it's just got, we're at 1 kilohertz now on the meter, and we're at -4, but if we go to about 300 or 400 hertz, that's 400 hertz, it's just pegging the meter, and that's with all the enhancements set off and the equalizer a bit manually optimized for my intentions. And the same is true if we go to the 5 or 6 kilohertz range. We've got like, that's at 5 kilohertz range plus 4 decibels compared to the 1 kilohertz reference as well. And the tone controls are centered at about 100 hertz and about 10 kilohertz, so I really can't do anything about these peaks using the internal DSP of a TV, because I can't get access to any more advanced equalizer settings. So all in all, sadly the sound output of this thing is very limited, in that it's simply optimized for the internal speakers in the TV, which seem to have a deficiency at 5 kilohertz and 300 or 400 hertz. And sadly, this is going to make any external speakers connected sound, well, very low treble-y and mid-bass. Yeah, that's not going to be very pleasant at all, unless I find some very suitable speakers. So, in light of that, I think I'm not going to add an external speaker connected to this TV. It would just gimp any external speakers a bit too much. But hey, at least we got to have a bit of a look at the insides of how the audio stuff in a modern TV works. And they certainly have optimized the DSP in the TV for the original speakers. It's not just putting out a flat frequency response to them, not by far. And if I hook them up and listen to some known music on them, they do sound relatively flat, as long as you're not talking about any high or low frequencies. So I really think LG have done the homework and basically flattened out the frequency response of their own speakers, and you really can't blame them for that. So what I'm going to do instead, since I am determined to hack this thing, is to just add an external power output for my Boston acoustic soundbar. If you haven't seen the video on this thing, it's something I also picked out of the trash quite some time ago, and it works perfectly fine now, except for the input select button, and it's even got its own remote control, so it'll do an excellent job amplifying this TV. And above all, it's actually made for 32-inch TV, so it'll look great mounted underneath. And we really are in luck about doing that, because the power supply rating for the Boston acoustic soundbar is 18 volts at 2 amps. And if we have a look at the ratings on the LCD TV supply, we can see that there's a 20 volt rail, which is the one feeding the audio amp. Now that one's rated for 20 volts at 1.1 amps, and that's gonna be close enough to run the soundbar, no problems, as long as I don't plan to turn it into a discotheque. And it's a good idea to double check stuff like this, because this is probably a group regulated power supply, and indeed the 20 volt rail is quite considerably higher than it's supposed to be. If I didn't know that the Boston acoustic soundbar worked fine up to about 25 volts or so, I would be in trouble. And there we go, a little plug mounted sneakily underneath the TV. And here's the entirety of the mod. So I've just got this generic DC connector screwed into the plastic. It's sitting quite tight indeed, with 2 leads going off to this screw terminal, because I can't be bothered putting a more proper connector in there, from which one wire goes to this little row of ground pins they seem to use for some kind of board identification stuff, and another wire going to this point here, which is the 20 volt rail. So this plug should just be putting out 20 volts DC whenever the TV is on, so let's try it out. Alright, so I made this little DC plug to DC plug adapter from a couple of old wall warts, so let's see what happens. And we've definitely got our 20 volts coming out of there. Correct polarity and everything. And it even goes away when we turn the TV off, so that's perfect. So there you go, that's a trash-picked 1080p 32-inch LG TV repaired and modified to power my little soundbar. So, thank you for watching. Cheerio. And if you're curious, that's where the TV finally ended up, sitting right above the ceiling, in front of my bed. So, I suppose I don't have any reason to ever get out of bed anymore, so I guess this is the last video of the channel. Goodbye everybody, see you never again.